on the balanced chemical reaction equation. So here's an example. Now we've been doing this kind of calculation all along in chapter 4. We give you a scenario, and we give you a chemical reaction equation there, and then we ask you to do calculation. Now, this time, when you do stoichiometry problems there, you should fall in love with this word. Every time you see the word excess, that means the other one is going to be the limiting reactant. The other one is going to run out. Okay, so in this case, according to this particular reaction, zinc reacting with hydrochloric acid, generating zinc chloride and hydrogen gas. Now, this reaction is balanced if we put H2 in front of HCl. Yes, here you have one zinc on both sides, two hydrogen on both sides, two chlorine on both sides. Okay, so the chemical reaction is balanced. Now we say, in this particular, I was looking for that number there. When you have 21 grams of zinc metal, how many grams of zinc chloride can you produce with excess amount of hydrogen chloride? Well, the hydrochloric acid, we call it hydrogen chloride. Hydrogen chloride is a gas. You have to dissolve it in aqueous solution. So this is hydrochloric acid once you dissolve it in water there. Now, if we put the word excess in here, that means you will have unlimited supply of hydrogen chloride. Therefore, whatever amount of zinc metal that you have will determine how many grams of zinc chloride you're going to get. So doing this calculation, this is the information given there. We have 21 grams of zinc with excess amount of HCl. How much? Well, we don't care. As long as you have enough, and more than enough there, and that's excess. Now this is the information we're trying to figure out. How many grams of zinc chloride can we get? Now again, this is the question that we cannot go from grams of zinc directly to grams of zinc chloride. You have to go through that detour there. You have to convert 21 grams of zinc into moles, and then there's a 1-to-1 molar ratio there. Every mole of zinc will give you 1 mole of zinc chloride, and then you convert the number of moles of zinc chloride that you are supposed to produce back into the grams there. Okay, so in this case, again, grams of zinc to moles of zinc, and moles of zinc chloride to grams of zinc chloride. And that's the path you have to go. There is no shortcut. Okay, and when you look at the grams of a particular reactant there, you cannot get directly to the grams of the product. And you have to go through this route here. Okay, so in this case, we have 21 grams of zinc, and the atomic mass of zinc is 65.39 grams. For each mole of zinc, it's equivalent to 65 grams. So if you have 21 grams, as we say, when you do dimensional analysis, you always multiply the conversion factor. Make sure you focus on the unit. You can cancel out the unit there. So gram and gram will cancel out in this case. You end up with 0.32 mole of zinc. Okay. Now, 0.02 mole of zinc, you can convert that into moles of zinc chloride. It's a 1-to-1 ratio. That is in the balanced chemical reaction equation. Each mole of zinc will produce 1 mole of zinc chloride. Okay. And mole of zinc will cancel out. You end up with moles of zinc chloride. And then we can convert moles of zinc chloride into grams of zinc chloride. And using a conversion factor of molar mass, 1 mole of zinc chloride equivalent to 136 grams. Now this number, you obtain that by adding zinc and 2 chlorine together. So you look at the chlorine is 35.5, somewhere in that neighborhood, times 2 plus 65. You end up with 136. Okay, so a mole of zinc will cancel, zinc chloride will cancel out. You end up with 44 grams of zinc chloride. And as we said, since we have excess amount of HCl, when zinc is completely reacted, when zinc is gone, you can no longer get any more zinc chloride. So in this case, we ask you the question, which one determines how much zinc chloride can you produce? Well, it's zinc. We have excess amount of HCl. Okay. So in this case, again, every time when you do stoichiometry question there, when you see the word excess, that means that particular reactant is more than what we need, and you don't have to worry about the quantity of that chemical, and then whatever quantity of the other chemical given to you, and that chemical is going to be your limiting reactant. You do your calculation based on that amount. Grams converted into moles, molar ratio taken into consideration, and then moles of the product converted back into grams. Okay. Now, in this case, when we try to identify the limiting reactant, we say the limiting reactant is one that runs out first. Okay, anything that's in excess, well, we have more than enough there. So the limiting reactant, zinc is the limiting reactant. Zinc will determine how many grams of zinc chloride you can get. So how do we find limiting reactant? Well, in a chemical reaction there, well, it's easy. If one reactant is in excess, then the other is the limiting reactant. Well, unfortunately, things are not always going to be this easy. You may not see the word excess. Well, every time when you do a stoichiometry question there, when you don't see the word excess, that means you have to find out who's going to run out first. Okay, so instead of doing chemistry, let's give you some analogies here. And some more recipe. Ask for 2 pieces of cracker, 1 chocolate bar, 1 marshmallow, to have a complete product. Okay, so if you have, if you do 6 crackers, if you have 6 crackers and 5 chocolate bars and 6 marshmallows, how many final product do you get? Hey, wake up, people. It's chocolate, marshmallow. So you can only get 3 because each final product requires 2 pieces of crackers. You have 6. And when you finish making 3 products, you use all of the crackers. You may have excess amount of chocolate bar. I can eat them, no problem, but you won't be able to get the final product. So the limiting reactant is the one that gives you the least amount of final product. That's what you need to figure out. So in this case, and if you make 3 s'mores, and you will use the total amount, you will use 3 pieces of cracker, 3 chocolate bar, and 3 marshmallow. And you would have 2 chocolate bars left over, 3 marshmallow left over. Okay. So in this case, the limiting reactant is the crackers. Okay. So that's what you need to be able to figure out in chemical reactions. There, you need to be able to identify the component, the reactant that will run out first. And then when you try to make predictions about how many final product, how many grams or pieces of final product you're going to get, well, you base your prediction on the quantity of the limiting reaction, not the other 2 reactants. Or otherwise, you may say, well, you end up with 5 final product or 6 final product there. No, you can't get more than 3 final product because one of the ingredients is going to run out. So these are the excess components, equivalent in the equivalent to the chemicals in the well, they are chemicals in a way, okay? In a chemical reaction. Okay, so limiting reactant, by definition, limiting reactant is the one that runs out first. And a limiting reactant is the one that makes the least amount of product. And there are different ways for you to do calculation. One is that, say, if you have multiple reactants there, each reactant, the amount of each reactant is given to you. Now you can do a calculation, and going from each reactant based on the molar ratio in the balanced chemical reaction equation, each reactant based on the number of moles of each reactant, you can figure out how many grams or moles of the final product that you will get. And then whichever gives you the least amount of the product is going to be your limiting reactant. So sometimes the question you may see a question that asks you, which one is the limiting reactant? What is the theoretical yield? Now, if you do that approach there, calculating the final amount of the product based on the amount of each reactants there, well, when you get the answer there, you will see if you have